should we be worried? There's, you know, I'm in my background here, I've got this thing coming in and hitting Earth. So what are we going to do if one of these is coming at us? Do we have a plan, Chris?
Well, actually, yeah, we have a lot of plans. And this is interesting. It's something I've heard about for many, many years, but it turns out there's been some recent progress on this, something I'll show you in just a second. I want to make the point, just so everyone understands, scientists do not at this time know of any asteroid that for sure is definitely going to hit us at all. It's just the possibility of it. There's some that come pretty close, and we keep an eye on them very carefully. We're always calculating the odds that one of them will actually get close enough to be a problem, and more on that a little later from another correspondent here. But the idea of an asteroid coming in that would be big enough to cause real trouble, this is something Hollywood has dealt with for years. We all know the answer. The answer is, of course, they send up a rocket ship with a gigantic nuclear bomb, and a bunch of very handsome astronauts blow the thing to smithereens. They vaporize, they powder that thing. It's understandable because an asteroid is a big risk if one is coming towards us, sure. And nuclear weapons are about the most powerful tool most of us can think about. Of course, you'd think to use it. It turns out that's not the best answer for these kinds of things. One of the things in all of our discoveries of comets and asteroids, both, especially asteroids, flying missions to them, like this picture here of the asteroid Ryugu, this is by the Japanese space program that sent the probe here. They are piles of rubble. They are not a giant stone, a solid piece of rock, not by any means. The thing to think about, they're really more like gravel. And gravel being held together, sure, some boulder size, but smaller stuff too, even dust, held together by weak gravity. These objects don't have strong gravity, so that it'd be easy for them to fall apart. Well, if you used, you know, a giant explosive to try to pulverize the thing, you might succeed, and that would be the worst thing you could possibly do, because now instead of one object coming your way, you might have 10, you might have 100, you might have 1,000 of these headed your way. This is not the strategy you want. Think of it this way. If the Earth is the target, the name of this game, your aim, is to miss. You just need it to miss. That's all you need to have happen as it's doing this delicate ballet of going around the sun, which means you just need to move it off the target. And the target is small. In some of the diagrams you just saw, it was like the swarms of asteroids around the Earth. It may have seemed like the Earth, it couldn't escape, but you got to remember, the asteroids and comets and the Earth are very small compared to the vast expanse of space. The Earth's a small target, and consequently, it's easy to move something off that target. You can think of it a little bit more like this. This is more like a game of cosmic billiards. A ball is headed toward the corner pocket. You don't want it to go in. All you have to do is produce some small change in its path. You don't need to pulverize it. That's the worst thing you could do. So maybe the answer is just to give it a tap, a little tiny nudge to deflect it. Well, here's where the news comes in. We've been talking about doing this for a long time. I got to admit, I was a little surprised when I looked into this and I found out we're about to try it right away. As a matter of fact, the DART mission, this is a NASA mission, is going to launch in another month or so, and it is going to send a spacecraft out there, the DART spacecraft, to a double asteroid. Didymos is the name of the asteroid, Didymos A and Didymos B for the moon. And what they're going to try to do is slam the spacecraft into Didymos B. Now, it's not enough to pulverize it, not enough to break it apart. It's a cosmic tap. The spacecraft isn't that big, but impacting at a high speed of 6.6 kilometers per second, I believe, this spacecraft should be able to produce a change, a subtle change in Didymos B's orbit around Didymos A. A slight change in the orbit. That's the skill we need to get, and they're going to try it. So September 2022 is when the actual slamming of the spacecraft into this is going to occur. They picked a double asteroid, by the way, but there are a number of them. But the reason they picked this one is because the laws of gravity, if you have two asteroids going around each other, it allows you to calculate very precisely their positions for as they go around one another. You can clock it. So it's easier to get a sense of the change in the orbit. By the way, the European Space Agency is going to send their own spacecraft, the Hera spacecraft, over to this system and have a look at Didymos B to study the crater and see how it behaved. So asteroid avoidance, mitigation, planetary defense, call it what you want. We're about to try it. So launch coming up, and we'll cover it in that and out to launch when the time comes. Now, that doesn't mean you couldn't try other things, like, for example, nuclear weapons. You could use a nuclear device and put it not inside an asteroid, but right next to it. And the trick here is that you heat the asteroid up tremendously on one side. And when you do that, the surface part of it will turn into gas and blow away into space. Well, that works like a rocket motor. That will push the asteroid slightly in the other direction. So we have no plans to do anything like this. It's a theoretical idea, but you could use a nuclear device in that way to nudge an asteroid or what have you to the side a little bit. And the same trick, by the way, can be done in a much more gentle way using mirrors, spacecraft that have parabolic mirrors to collect the sun's light and just use sunshine and focus it like you would with a magnifying glass, focusing the sun's energy to a small spot. That could heat up a part of the asteroid, produce the outgassing, and do the same thing. Now, the weirdest and most exotic idea is what I'm calling a tractor beam, but I'm joking a little bit. They call it a gravity tractor. And that even a spacecraft, small as it is, has its own gravitational field. It's not strong, but any matter has its own gravitational field. For a smaller asteroid, okay, smaller, not one of the really big ones, but with a small one, the gravity of a spacecraft, if parked near it or maneuvering around the asteroid in particular ways, could actually exert a little gravitational pull on the asteroid and could change its path. They call that approach a gravity tractor. Again, it's theoretical possibility. Now, no matter what it is that we do, which approach we use, this is something that's going to need to be done carefully, thoughtfully. You're not going to just go blow something up. People are looking into it. They're testing it now. And we're going to take our first very careful shot with Didymos starting next year. So good news. Glad to see we're thinking about this and getting ready to protect ourselves. It's good stuff.
It's something we definitely have to do. It's a real danger.